The students were taking a really fun course in environmental applications of remote sensing, both from drones and satellites. And so they understood sort of the large data challenges and some of the data types. And what was really fun was to go in and package this new idea of applying machine learning to these data sources. And so both for the students, it's a real world application. If they're going out there and they're going to be a geospatial analyst or a remote sensing specialist, they're going to be using these tools, these computer vision tools. And for me, I've been working on this for years now, and it's really fun to try and package it into a form that can be digestible, that can be teachable, and it of course helps me learn the topic a lot better.
The things that we're teaching students now, modern techniques about population assessments or photogrammetry to understand the body condition of an animal, now require new tools because they're so data rich. And doing it manually is almost impossible.
We had a number of drone surveys of seal colonies, and the end product of a drone survey over these seal colonies ends up being a 3D model of the colony, as well as an RGB or color mosaic, basically a really large image that maps the entire colony in really high resolution, so just a couple centimeters. And what we wanted to do was do a census, try and count how many seals there were across all these colonies. The real challenge is when you have thousands or tens of thousands or even more in each colony and maybe multiple time steps, it really becomes a burden to try and count all these individuals. And so we were applying new machine learning techniques which sort of fall into the field of computer vision. So we were applying convolutional neural networks to count all these seals. And our data expedition was packaging that into a teachable unit to show students how you can take complicated remote sensing and machine learning concepts and apply them to answer really interesting and important ecology questions.
One of the really great things about bringing data science into the classroom is that we spark all of these young minds to think about things in new ways. So they're much more familiar with these kinds of new tools than I am, and so I learn constantly from them as they bring new ideas, new concepts, and new approaches to these long-term problems that we've been trying to address. And that I often get much more out of that than they probably do.
When I package this for a class, we always try and make it sort of open source, open access, both the code, the data, and the teaching materials. And for me, reproducible research is a really important concept of my scholarship. And so this is always a nice way to step back and say, okay, we want all this to be reproducible. I want all my work to be reproducible. And packaging it for undergrads to digest is a really nice way to make it truly reproducible for anyone. I think many of these topics are compartmentalized, and across institutions and across the fields, they actually don't talk to each other well. Computer scientists and ecologists and remote sensing specialists. And I think it's critical for each of those fields to grow and develop and to address real issues, to actually be working together. And this course was a nice little case study in collaboration of those different fields. And it is exciting at Duke to be merging computer science and ecology and teaching it to students, and students teaching me about these topics as well.